This equation is abstract. It's a quadratic equation. By that I mean the variable is only going to be a number. It doesn't have a tangible meaning. But we can solve using geometric numerical method. The coefficients are -3, -1, plus 2. Okay. This is a minus, b over 2. So that minus times that makes this a plus. So I have 1/2, 1 divided by 2, and I'll put it here also. Then I have a, which is -3, and then c, which is a 2. When I do this multiplication, 1/2 times 1/2, I get 1/4, 1 over 4. When I do this multiplication, I get -6. It's always subtract the two cofactors. So a minus times a minus is a plus, and I have 6 and 1/4. When I multiply 6 times 4, I get 24, and then 1 is 25. So I have 25 over 4. So the deviation from a trinomial square is 25 over 4, and it happens to be a perfect square. In other words, the square root of this is 5 over 2. It means the roots of this will be rational. That is a fraction, ratio of two whole numbers, or a whole number. So the roots will be 1/2 divided by -3, which makes that a -1/6. The deviation will be the square root of 25 over 4, which is 5/2. But then when you divide 5/2 by -3, you get 6 in the denominator. So it's 5/6. This would be the root if it was a trinomial square, and this is the deviation from a trinomial square, 5/6. Okay, now the vertex is the same as this, -1/6, that's the x-coordinate. The y-coordinate is -25 over 4, divided by -3, which makes that a plus 25 over 12. 3 times 4 is 12. And they're both minus. This is a minus, this is a minus, so we get a plus. So this is approximately 2, 12 and 25. So the vertex will be right here. It'll be -1/6. It'll be to the left of the y-axis. And it'll be a little over 2. And then the roots will be rational. -1/6 plus 5/6 is 4/6, or 2/3, plus 2/3 and a 0. And this -1/6 minus 5/6 is -1. So this is -1, 0. So we have these 3 points, and we can sketch the parabola. This equation is abstract. That means a variable will not have a tangible meaning. It's only a number. But it's a quadratic equation, 3x squared minus 6x plus 13 equals 0, because I want to compute the roots using the geometric numerical method. This is the deviation from a trinomial square. Minus 6 over, divide by 2, I get a 3. I get a plus 3 because this is also a minus b over 2. So that sign is going to flip. So I put a 3 here and a 3 here. The coefficient of the x term a is 3, and the constant is 13. So I get that very quickly. 3 times 3 is 9, and 3 times 13 is 39. When I do the subtraction, I get -30. What this means is deviation from a trinomial square is -30, and this minus means that the roots are going to be complex numbers. as we'll see. So x, the roots, will be this 3 divided by that 3 by a, and then plus or minus the square root of minus 30 divided by 3. What we do is write this as 30 times minus 1, and then we divide the square root of minus 1 as we give it the letter I. So the roots are going to be 1 plus or minus square root of 30 over 3 times this thing I. The vertex will be that 1, that's the x-coordinate, and it'll be minus this, minus a minus is a plus 30, divided by a. So we get, when you do this, 10, 1 comma 10. There it is right there. And then it does not cross the x-axis. That's what we mean by complex numbers. When we get a negative square root of a negative number, it just means that the parabola will plot above the x-axis and it doesn't cross, except their imaginary complex number 1 plus or minus square root of 30 over 3 times I. Again, I just did 6 arithmetic operations and I get the roots and the vertex. So the geometric numerical method is, for solving quadratic equations, is quite easy. In this clip, we are going to solve an exponential equation using symmetry and reformulation. An exponential equation can only be solved using logarithms if the exponent is not a whole number. If it's an irrational number like this problem, then we have to use logarithms. And the change of base formula in logarithms is what allows us to reformulate such that we get translational symmetry, as we'll see. In this clip, we have an exponential equation. 24 is equal to 5 times 2 raised to the x power. We want to reformulate till we get symmetry. The first thing we'll do is reformulate 24 to match this coefficient. So I'm going to multiply by 5 and I'm going to divide by 5. That's the same as multiplying 24 by 1. When I do this division, I get 5 times 4.8 is equal to 5 times 2 to the x power. I now want to change this base from 4.8 to 2. I will use the change of base formula in logarithms, and it goes like this. You take the log of the old base, logarithm of 4.8, and you divide by the log of the new base, log 2, and then I'll put a 2 in here. So I have 5, everything match. I get translational symmetry when I do that. So this exponent x must equal this exponent. I wrote it down here. These can be computed, and this is what you'll get, 2.263. Let's check to see if this is reasonable for x. If x is 2, this will be 2 squared or 4. 5 times 4 is 20. That's not enough. If this x is 3, 2 raised to the third power is 8, and 5 eighths are 40. That's too much. However, 24 is closer to 20 than it is to 40. So this exponent is going to be closer to 2 than it is to 3, and that's what we got. If you formulate it in logarithms of the base e, which is what we use in scientific notation, logarithm of 4.8 to the base e, and then divide by the logarithm of 2 to the base e, you will get the same answer. in this problem, we have 3x, x raised to the pi exponent, pi power. Pi is 3.14159, so it's not a whole number, so we're going to have to use logarithms. Minus 7 equals 4. 3x to the pi minus 7 equals 4. We're going to reformulate 4 so that we get a match on this minus 7 first. So we have 4 plus 7 minus 7. So we have our match. Now I want to match this coefficient. So I'm going to multiply by 3 and I'm going to divide by 3. So how does this base come out? 11 over 3. Whereas this base is x. I want to change this base, 11 over 3, to a new base, x. And I can do that using the change of base formula in logarithms. And it goes like this. I'm going to take the logarithm of the old base. There it is, 11 over 3, log of the old base, divided by the log of the new base, which is x. And then I'll put the new base there, x. When I do that, I have translational symmetry. So everything matches, so that exponent pi has to be equal to this. So here it is. Now what I'm going to do to this equation, I'm going to multiply by logarithm of x divided by pi. And when I do that, I get the log of x on this side, and I have known numbers on this side. All right. So when I take the logarithm of 11 divided by 3, and then divide by pi, I get this number, 0.41357. This exponential equation is the same as this log equation, only the inverse is taken. This is the base e. Ln represents the base e. This means base e raised to this power is equal to x. When I evaluate this on my handheld calculator, it has that function. X is 1.51221. In other words, about 1.5. If I put 1.5 in here and raise it to the pi power, multiply by 3 and subtract 7, I will get 4. So we solved it using symmetry, reformulation, and we have no choice but to use logarithms. This ends our video on visual algebra through symmetry. Visual algebra is geometric algebra with symmetry substituted for geometry. The visual method works like this. You reformulate one side of the equation until you get translational symmetry. You get the form of the equation on both sides to be the same, and then by one-to-one matching you can determine what the value of the variable is. Visual algebra is based on a natural concept, symmetry of the human form. Everybody knows what it is, even if they can't define it. And everyone has done the experiment where they match their thumb to the thumb and index finger to index finger and so forth and get one-to-one match. You get a perfect match. One-to-one matching is a natural concept. Symmetry is a natural concept. So visual algebra is easier for the students, especially those students that are somewhat limited in their mathematical ability. I found from direct experience that you cannot possibly teach exclusively the axiomatic method. If you do, you're going to lose so many of the students. And most of my students in the community college are majoring in a discipline that is completely devoid of mathematical content. They have to get through intermediate algebra, what I had in the 9th grade, in order to get a license to take some job in say in Child Development Center. The axiomatic method is based on a concept of formal proof. It's a human invention that dates from the 4th century BC. And axiomatic algebra has a certain structure: assumption, deduction, conclusion, and the abstract symbolic logic that's required to solve the equations using the axiomatic method is beyond the scope of many of the students. I have found from a direct experience that if you teach both the axiomatic method and the visual method in parallel, the pedagogy will more likely fit the profile of a typical class in algebra.